currently serving as an assistant professor in Department of Artificial Intelligence and Machine Learning at Techno India University. Her research interest includes cybersecurity, deep learning, machine learning, and intelligent network systems, reflecting her dedication to advancing research in cutting-edge areas of technology. We are honored to have her with us today and look forward to gaining valuable insights from her presentation and research expertise. Please join me in welcoming her. Thank you.
Thank you, Vanu, for the nice introduction. Thank you all. Hi, good afternoon to everyone. I'm Sukriti Santra. I'm working as assistant professor in Department of Artificial Intelligence and Machine Learning. Today I will discuss review paper. So here my presentation. Let me share my presentation. Is it visible?
Yeah.
Yes, ma'am, it is. It's just got unshared, I guess. Wait. Is it visible? Yes, it is visible. Okay.
Yes. Yes.
Okay. So today I will discuss a review paper on graph neural networks for financial fraud detection. So basically in this paper, the rapid growth of financial frauds, how we can detect with graph neural networks and what are the challenges and future benefits. In this particular review, the authors have explored and they have cited over 100 papers, and from their these they basically in this paper they have addressed these 5 research questions. So what are these research questions? How can various graph neural network methodologies in financial fraud detection be understood through a unified framework, and why we will use graph neural network for this financial fraud detection, and what are their roles, and how to design these new graph neural networks which are suitable for this financial fraud detection, and what are the real world applications and how it can be deployed. And basically many companies, big companies representing their data using graph. Okay, so now to detect financial fraud, how this graph neural network can be applied. Like any financial fraud doesn't depend on like features, unlike the machine learning or deep learning. It has some relations also, how what their transaction is happening, how many transactions they are doing, and based on that, how these graph neural networks can be formed and how it can be applied to different scenarios. And what are the major challenges and what are the future directions in this paper basically they have addressed. So basically, if we think that um, in 5 sections they have like financial they represented how financial data can be represented as graph like account and users as the node and transactions as the age and the merchants as node like this node represents node and using nodes and ages we can represent the all financial transaction between the users and merchants and from which devices and from which institutions these acting like transactions happens we can represent using these graphs. And for financial fraud detection, there are many different types of graph neural networks available, but mainly they have focused in these 4 different types of graph neural networks, like graph convolutional networks, graph attention networks, graph temporal networks, and heterogeneous graph neural networks. So basically, the application area they have addressed here. So we will discuss that how these are useful in this fraud detection, financial fraud detection. We will discuss one by one, and then they have like explained that how these financial fraud where we can apply this, like in credit card fraudulent, money laundering, insurance frauds, online payment frauds, e-commerce fraud, and uh, like account takeover. All these are like these are very crucial for in today's era. Like we are everything we are doing with the internet, and all the transactions we basically do online. So in that case, that financial fraud detection is a very like crucial area where we should keep our we should apply our like way of thinking that how we can detect these financial frauds in efficient way. So while like in this paper they have explained like how why graph neural networks we will use. So there are some like advantages of using GNNs and what are the design consideration of graph neural network, like it how the graph is formed and how basically in graph neural networks graphs are formed with these account transactions and each node they they store their features. Like in case of simple graph, as we know that in graph we have nodes and edges. Yes. Yes, nodes and edges, and each node has some features that how many like edges going out from that node, how many edges coming to that particular node. In case of financial portfolio, there will be some other features, so they store features and they share the features and uh, this way this graph neural networks learns everything. So in that case, how to design this new graph neural network to detect transactional fraud, and then what are the challenges like scalability challenges is there, class imbalance challenges there. Okay, then interpretability of GNNs and what are the future directions, and from this what are key findings, like this we will discuss in this particular topic. So basically, if we see that unified framework for GNN-based fraud detection, data are collected and then graph we construct and then we model it using GNN, and then training validation is done, and then fraud detection happens and we interpret and then we improve our detection and reduces losses. Okay. So basically, in this particular review paper, what research challenges they are addressing, like this is financial fraud involves integrated relationships among multiple entities. Like what are multiple entities? Like accounts, devices, merchants, transactions, institutions, like this. And now, how we and these are dynamically evolving, isn't it? That if the fraudulent activity is happening, So this time they are taking this some method, and after some days or sometime they are taking other methods. They are also evolving in this era. So here also that class inverse normal, like normal activity is more than the like fraudulent activity. So there is a problem of class imbalance. So fraudulent transactions are extremely rare compared to legitimate ones. So this is like if we are creating a model, that could be a bias model. And then we have heterogeneous multimodal data, like what? Multimodal, that means that data comes from multiple sources, and in the data are in multiple formats. Like some data are structured, some are semi-structured, as some network relations we are getting, some behavioral data we are getting. So these heterogeneous data we are getting, and also these financial transactional data are highly sensitive. So centralize this collecting the data in a central server, which is like which causes privacy issues. So which can violate some regulatory compliances like GDPR, CCPA, etc. And also other problems are like scalability in large financial runs. Like real world financial networks contains million. If I think of banking data or any like Amazon online e-commerce website data, these contains millions of like transactional data where no like entities are there, which we represent using nodes and edges. So learning efficiently that large scale graph, we have computational limitations as well. So this is another challenge. Okay. Now, in this particular, what is the goal of this paper? Basically, in this paper, the authors have explored how graph neural networks can effectively address these challenges and improve the accuracy and adaptability, so that we can deploy these type of models in the real world to detect financial fraud efficiently. So now, before diving into details of how graph neural network can be used in fraud detection, let us first understand what is GNN and how does it works. That we should know. Okay, so basically here you can see that this is deep learning models which are designed to operate on graph structure. So, if we have data other than any text, like we basically in deep learning we apply data like for LLM we take textual data, we represent it in using vectors. In case of image, we form graphs. Sorry, we form pixel matrix, and then we feed into that model. So like that, in this graph structure, we represent that using a graph. Okay, so node represent entities like who are actors of the in this particular in case of as we are discussing using fraudulent activity detection. So we are taking it user accounts and all that. And but if you some Twitter, they are representing their data using graph to the users and how they interact with others. Facebook, this way we may think. And then age represent relationships that this particular person has transacted by bought this particular item via this bank. Like this we can think of. And GNL learns the representations by aggregating information from each other. Like suppose this node will share its features to this node, and this node what it will do, it will read the shared features, also it will add its own features and then share. Like this, by sharing the data they learn and they aggregate the information. Okay, so why GNNs? Like complex relationship it can capture, and it can discover hidden patterns, And it like in these particular domain, like fraud detection and how social networking in these particular area, the problems that we want to address, it can improve the detection accuracy and also adapts to dynamic evolving graphs. Like in case of fraudulent activity, it's not like we are making a static graph and it will go for like long. So the transaction is happening, like it is dynamically changing. So that it can adapt to that nature. So that's why we, we can use GN. So here are some examples in financial fraud detection, like transactional graph, like relationship graph, device graph, information flow graph. So this way we can represent these particular like things like transactions, relationship, device in form of graph, so that we can train our model using graph neural network. And how does GNN work? As I told you that each input, like this node, suppose this is X, these inputs have some features. So each node has initial features, and age defines the relationship. What is the relationship with the C? So like then in step 2, what happens? They pass messages. Okay. And then they aggregate and update. Each node aggregates a message from the neighbors and update its representation. And then what they do, they repeat it for k time unless it is getting that higher accuracy. And then final node representations are used to downstream tasks. So like this, they detect like the classify whether the activity is fraudulent activity or normal activity. So basically, GNN iteratively pass and aggregate information and process tasks so that each node learns from its local neighbors, and so that it can like in global context it can detect. Now, why in fraud detection we will be using GNN? So in the traditional method that are like mentioned in this particular review paper are rule-based methods. There are fixed rules. So if it is rigid fixed rule, it is very difficult for new patterns, and as this particular domain is dynamically evolved. Okay, so now logistic regression is there, like but in logistic regression, all the transactions are thought of like in isolation, not how they are related. We cannot see using logistic regression. And decision tree, graph relationship, we can't model it, and random forest, no relational reasoning. So these are the models, traditional models that have been used in financial fraud detection, and these are the challenges that are faced, mentioned in this particular paper. And in this graph neural network, what are the advantages of using like in fraud detection? Like it can understand complex relationship, as everything is represented using graph. So relational pattern learning, multi-hop neighborhood, neighbor message passing. Okay, and automatic feature extraction is happens. Like we no need to like tell that which features you should take and which you should not. Automatically it can like extract the features, and dynamically it can model, and we can multiple type of data text, like we can unifiedly represent it in using a graph neural network. So basically in this particular traditional method, it's detect the things in isolation, but how they are related, that cannot be detected using these particular methods. But using graph neural network, we can like complex relationship we can capture, and we can represent it, so that it is useful for adaptive environment, like in financial transactions are happening like every time. So the model should be adaptive also. So now in case of financial fraud detection methodologies, so these four types of graph neural networks they have addressed. So basically in GCN, GAT, like GCN graph convolutional networks, This neighborhood average layer by layer captures local structure and fast and scalable for larger graphs. And it captures local transaction patterns and effective for homophily networks. And weakness, what are the weakness? Like over smoothing and depth. Okay. So the pattern that I have discussed, that it is learning from the neighbors and then aggregating the features, that is for one layer. So in case of deep learning, there may be multiple layers in graph neural network also. Okay, in graph attention network, like it is in graph attention networks, like it finds that which particular node is important for a particular thing. So it calculates that important node. So learn attention score per neighbor and focuses on the most relevant conditions. So noise based, which are most useful, it only consider that. So this is higher computation cost than this, as it has to compute that which is most relevant, like this. And then in graph temporal networks, like it combines like the graph convolutional network and RL temporal. So it like at time, it's like works like it has a memory. So it remembers that at time t1 how it was, then at time t, and then next time t plus 1 to capture sequential fault patterns. So it can model the evolving relationship as it has this time window. Okay, so it can remember the past events. That's why. So that's why it is graph temporal networks. So many different types of graph neural networks are there, but in case of financial fraud detection, these four majorly are mentioned in this particular paper. So heterogeneous GNN, heterogeneous GNNs, we can use multiple nodes, as in case of limitations, we were discussing that the data can be of different format and it is coming from different uh, area. So in that case, these can that problem can be handled by heterogeneous GNNs. Multiple node edge type in one graph made up of these are the more complex to design and train, but it can handle all relationship data well. Okay. Now, now the thing is how we can build the from the financial data, how we will build the graph. Okay. So in case of this transaction graph, relationship graph, behavioral and device graphs, we can build. Information flow graph is there. So in transaction graph, basically these nodes are like who are the actors of the transaction, and the multiple entities are nodes, and transfers and payments are edges. Detects unusual flow pattern, rapid small transactions, and sudden large fund movement. So in these particular age, this is representing the transaction and also the features, how much the transaction is happening. If something larger transaction or some pattern, it will be, it can detect if we represent this transactional graph. And relationship graph, like individuals and companies, capture ownership, control, and corporate structure, and reveals cooperation networks behind money laundering or insider trading. And this is like behavioral and device graph. So these are like devices whose account is connected, login patterns, and how that at what time the transaction is happening. So it can capture that. Okay. So in multiple accounts, how a person, suppose logged in from multiple accounts, and how that if a fraudulent activity is happening, then how their login patterns and what are those their devices ID and how their transaction is happening. So this behavioral and device graph is created, and then information flow graph, how the like news, social media and announcement to market activity identifies information manipulation influence centers in the market, like news and what accounts, how the information is influenced. Using this information flow graph, we can understand why we need multiple graphs, like to capture the transactional graph, relationship graph, behavioral and device graph, information flow graph, we are representing. Why do we need that? Because to capture diverse relationship and to detect hidden and complex fraud patterns, and so that we can integrate all these for multi-source financial like data. We can so that we can integrate all the information and to improve the detection accuracy, and so that we can enable the robustness and explainable models. Well, and what are the design challenges? As we have discussed that design challenges like imbalanced data set. So solutions, some solutions that are mentioned here are small graph smart, generate synthetic and fraud samples on graph, cost sensitive losses, penalize misclassification of fraud hires, ensemble GNNs, combine diverse models for robustness, and adaptive resampling we can do. And case of feature engineering, like what are the challenges in case of feature engineering? Like node features must go beyond account or frequency to capture info. Like complex pattern it can miss. So what are the solution for this missing the complex pattern? Like auto learning via message passing, learn rich node endings automatically, and age features as propagation weights, and then we can regularize it to guide the model to learn discriminative patterns. And the dynamic graph, like fraud patterns evolves over time. So in that case, if our graph is static, it can misclassify. So in that case, it should be dynamic. So in that fraud patterns shift constant. So static models become stable as new accounts and transactions arrive. So we must keep time decay functions like higher importance to recent interactions, and sequential dependencies we must capture, and also we represent update our endings with the new information, so that this dynamic pattern we can capture. And also another like important issue that are faced is scaling. Scaling is like when the financial data become larger, as we know that in this particular area that we are sending 10 rupees also online. Okay, so in that case, to capture all the information and to make it model learn, it is very like scalability issue are there. So now we can use for that the solutions that are mentioned here, multi GPU training. We can do this with caching we can do, and distributed training framework we can adapt, and we can use the graph partitioning. Like we can scale it across machine efficiency. According to the machine like capability, we can scale it by partitioning the graphs. So basically, these challenges, these are the challenges, and we must address these crucial challenges to build the effective, scalable, adaptive graph neural network that can detect sophisticated fraud in real-world financial system, which is very important. Now, in real-world applications, mainly in this particular paper, the four applications they have mentioned: credit card frauds, online payment frauds, insurance frauds, and anti-money laundering. So in case of credit card fraud, this is also best suited for this to detect this credit card fraudulent using graph neural network. So here we can like card holder, margins, and transactions we can represent using graph, and temporal, spatial temporal attention mechanism we can use to understand the pattern, and then using semi-supervised learning, like in a paper it is mentioned, with the attribute driven graph we can detect. So now in online fraud payment, like dynamic e-commerce graph, is model, it is mentioned in a paper, and dual level like transactional behavioral layers to dual level graph neural networks are like mentioned, and hierarchical attention is prioritized, which is key features, and then heterogeneous models for blockchain transactions are represented. And then insurance fraudulent for this insurance area, so dynamic scheme detection. So if like relational graph, like claims providers, patients, whether that insurance company, what if they are selling some insurance, and whether that party is getting the benefits properly or not, and how the if some fraudulent activity has happened, and in future how it can happen, we can understand this pattern using this. So using parallel graph neural architecture, we can diffuse the risk, and dynamic graph neural networks they have mentioned for evolving fraud schemes. And in this anti-money laundering, like anti-money laundering, like multi of graph traversal across laundering chain. Um, in this particular graph, like how like in interbank transactions, they in the money laundering, how it is happened, like from bank they have transferred to other bank, or they have taken in Bitcoin. So these can be represented using these particular type of using graph neural. So now from the card networks to crypto ledger, graph neural networks adapts in is adapted in diverse domains. So it can capture complex relationship to detect like sophisticated financial fraud. So it can detect complex relationship, hidden patterns of like fraudulent activity, and also it is adapting to evolving fraud. So in these particular, like what are the future open problems and future directions? In this particular paper, they have mentioned about that about scalability, explainability, adversarial robustness, and pre-training, and RL integration, reinforcement learning integration. So scalability, that means current like using how many nodes in a single GPU, up to 10 million nodes we can like train, but using multi GPU and distributed training, we can scale the network for training. And then we can explainability from the black box model, we can understand that uh, using explainable AI we can understand, so that what decisions they have made, that is auditable, which will satisfy that GDPR, all the regulations. Okay, so we can visualize the analytics that are needed. And adversarial robustness, like fraudster can poison the graph. So now we should like certified robustness method are needed. Like adversarial means there should be some those who want to poison this, they can change the graph structure. So there must be adversarial robustness as well, so that if something go wrong, that can be understood. And then retaining LLM style transfer learning for GNN, retain on large graphs, fine tune, we can do the fine tune. And then using reinforcement learning, we can make it adaptive, so that real time fraud strategies can be and using reinforcement learning, it can learn from the mistakes, and also so that we can combine with the GNE. So these are the future direction in this paper they have mentioned. So basically, the authors have mentioned the critical gap in this particular paper. There is no unified benchmark model, uh, are which are evaluated on different data set. Like that's why the comparison, making it the comparison impossible. And label scarcity, like fraud labels are rare and often noisy. Self-supervised retailing is a key open challenge. Like label data is less. Okay. So now real-time inference, the most models are batch trained. Online fraud needs sub-second responses. So in this particular paper, authors have reviewed more than 100 papers systematically, and they what are the usefulness of these four models of graph neural network they have shown. And then practical graph construction taxonomy, they have these novel taxonomy they have represented, and also they have covered the real world deployments across the four domains that already have mentioned, and what are the future direction this research can go. That also, that roadmap is also given. And in my opinion, what are the what things are left out, like um, data set. Uh, there is they have not mentioned about data set, and also and privacy preserving, about the security of graph neural network. It is not mentioned. Also, federated learning is mentioned there, but it is not mentioned elaborately. Like as we are as this data for the fraud detection, it is like privacy concern. We cannot it is not feasible to gather all the data in a centralized server and process it. So there is a need for federated learning for privacy preserving. This part is not mentioned elaborately, and how to label the noises in the fraud data set, that is not mentioned there. And like how we can train the GNN trained on credit card fraud transfer to insurance fraud. These are the discussion questions we can it can arise. Okay, and so from this particular paper, what we can understand that GNNs are not just one tool among many. They are structural match to fraud detection. Because fraud is a graph problem which should detect the patterns and the relationship, and they are unique features. And message passing mechanism is literally designed to discover the relationship pattern that fraud hides. So whatever open challenges it is mentioned in this paper, these are very crucial area, and so that these particular challenges makes these particular models fast enough, trustworthy, and robust for production deployment. Thank you. That's all. And if you have any question, you can ask. Thank you. Can I stop share, sir?
Uh, 1 second, ma'am. Thanks a lot for your wonderful presentation. We will now be moving onward with the Q&A session. So please keep your presentation open because we might need to refer back to it.
Okay.
Firstly, I would like to thank you a lot because your presentation was like really detailed on such a complex topic. We used so like there was a wonderful use of infographics there as well, and I was noticing the detailed pointers you used. So it was very easy to notice and understand. Thanks a lot for such a insightful presentation. Um, Now I would request all the audience to engage with the Q&A session. And I think as you can already see, there have been some questions asked in the chat box already. So please refer to those.
Uh, I asked Anisha to read out the questions one after another so that they can follow the questions. And if the other participants who are actually raising the question, they can also tell their questions once again what exactly they have floated in this particular chat box. So, starting in this particular starting of this question answer session, I will definitely thank you, Professor Sukriti Santra, for this nice presentation. And I have some few questions. I should definitely ask that questions, and that would definitely go into the mind of the other students, those who are working in this domain. Also, they will take the interest on that one. Okay. So, first of all, I have some very basic question. I think you have answered all those questions in your presentation too. But still, I have some particular query. Like, say, you have mentioned in one of the in one point that is the multimodal data is a challenge. Okay, so
Yes.
multimodal data is truly a challenge to model when actually you are going to predict something else for means your in your fraudulent activities in the financial systems. What you are telling, it's true, but isn't also an opportunity from the other end if you can see in that. And let's say, for example, one particular type of data is there, from that your model is being trained. Later on, if you actually have the multiple other options to do other modes to do over there, that could be the another kind of opportunity, I think so. Okay. So
Yes.
I think you might be agree with me that one, because we are
Yes, sir.
doing in our we are doing the many works in different domains. The multimodal activities are actually been taken in a very important consideration, and the people are doing the work in our research group also. So this is one very important point. Another point, I think is one point. It might be coming in the mind of those other participants that you are talking about the graph neural network. So graph is a drawn those figures and can tell me from your
Yes, sir.
presentation, so that it would be much
Yes.
more elaborative for the participants too.
Sir, in case of homogeneous, only I'm like if I am mentioning about the user, then it is
Yeah.
like same type of node I am discussing. But in case
Okay.
of heterogeneous, here banks are also there, and
Okay.
that from that which platform we are buying things, that is
Okay.
also there. So
That
this
means you are
is like
telling the
heterogeneous.
user and the where actually it is doing that particular
Yes,
activities, financial
it is
activities at a
different.
bank, or let's say, for example,
Uh,
any instrument, financial instrument. Let's say, for
yeah,
example, if you're using the credit card, debit card, okay, or in your UPI transaction, that could be
yes.
considered as a node in the network, right?
Yes, yes,
Okay.
because the features will be different. Like graphs are represented using some adjacency matrix,
Ah,
and the features are represented separately. And for a node, if it is account only, their features are different from other type of nodes,
yeah,
obviously.
yeah.
So that becomes heterogeneous.
Okay, I would ask the Artisman to ask the your question, and I will later on I'll be going for the next question.
Yes, sir. My question is, uh, in the financial fraud detection field, there are millions, billions, and billions of data. So, if we apply graph neural network on these data, what are the challenges that are rising? And another question is, we know that in most of the cases of financial fraud detection models, there is a decision engine which score the transaction risk. And for these graph neural networks models, how can we develop the transaction risks so we can give the decision engine the risks and analyze the required measurements to take.
I think, Artisman, you can take the questions means one after another. It's first question. If you what you have basically raised, means let her answer that question first, and then you would raise the second questions. It would be better for the communication for entire session.
Okay, so the first question is the here is the matter of the that financial data is in quantity of billions. So, what are the challenges developed for graphical neural network to apply in these billions of data to actually work?
Yes. Scalability issue is like main problem, as I have already discussed, and also data imbalance is there. Okay, and fraudulent activities, these are like dynamically changing. So for this we have that we can use multiple GPU training model, and also we can distributed frameworks that we have, we can use that. And also by partitioning the graph across the multiple like according to the machine efficiency we can apply, and also federated learning we can apply. This way we can solve the problem of scalability issues. And also we have different issues, like you mentioned that scalability, huge data, how we can handle it. So these are the like solutions that we can apply on
Uh,
it.
well, along with this particular thing, what exactly he has asked the questions, scalability issue and all those, I will add one very important question over here. Means, though the financial activities are actually in billions and means,
Yes.
trillions of that one, and at every moment, and there are a lot of transactions are happening, the data means, in your data set you could have that amount, but isn't that there is a scarcity that due to that the data means what the financial transactions are in are very sensitive data.
Yeah.
So isn't that a challenge to get the data for the research to means,
Yes,
getting the data, actual
is
data,
also challenging.
it's very
Mhm.
very challenging. I should definitely add this one,
Yes.
but the scale you could can think that huge data, a huge amount of transactions are happening every moments and every seconds, but though the data is not available, it's a proper data
Mhm.
for the for this particular kind of for this kind of activities, research activities, the data is not available. Okay, so
Yes.
this is a very important thing. Archisman, you can ask the next question.
Yes, sir. So my next question is, in the case of financial fraud detection, we know that many models use transaction risk coding method to develop a
Yes.
decision engines. And so for this graphical neural network, especially for the graphical attention GAT network, so how can we develop how can we combine these two things? How can we get the transaction rescoring factor?
Yes, like that you said correct that that GAT that model we can use, and for that some mathematical model we can apply like calculation to score the risk. Okay, that we have that we must see that how we can combine it. We can combine it with that model. That depends on the features, like how that graph neural model is learning the features from the patterns, and after that we can apply some mathematical like calculations to give the risk score. Okay.
Thank you, ma'am.
I have the next very important question. What I have basically, when you were showing me the multiple different types of network, actually, in a one particular, in one single context, you are showing that this is one another, this kind of relationship network, this is an information flow network, behavioral device network. So, means I was thinking about that thing. In this paper, what exactly they have basically surveyed. Did you find out any kind of work related to the multi-layer network structure? Different same things in the different layers are happening over there. One single transactions are reflected in the different layers. Is it there any kind of work?
Yes, sir. Like in graph neural network, there is like this structure. Okay, but in this particular paper, they have mentioned this. So,
okay. No, I'm basically trying to understand that multiple networks are actually being shown. Multiple network has been shown, but is there any multi-layered network concept is there or not?
No. Sir.
Multi-layer network is not there.
Yes.
Okay. So this could be a very interesting point, that if we can model this kind of activities in the network, a multi-layered network. Let me tell you that for the other audience, actually, I definitely tell that thing. What's the difference between the multiple network and the multi-layered network? Specifically, if you are just looking into this particular two terms, it seems to you that it's basically the same. It's synonymous, some kind of multiple networks are there, but there is a multi-layered and multiple network. There is a difference. Multi-layered means that every layer have some specific activities, and the theme of that particular layer is same. Okay, and if you are going for the multiple different layers, that one layer activity are actually are corresponding to the other layers too. Let's say, for example, one transaction is happening. So which accounts to which account the transaction is happening? This is one layer. This could be considered as one layer. Another layer, could be the thing that which instruments are actually playing the role over there. So okay, so that is another. And let's say, for example, in another layer, that what are the different, what kind of activities are happening? It is a shopping, it's a in a trouble payment, or it's a shopping in somewhere else. This particular thing is a different layer, but it is reflecting for a single activity, single financial activity. So that could be the very good model over there. Multiple layer have the different kinds of relationship amongst the different entities in this, which is actually forming the network. Okay, so this could be another interesting idea. If the work is not in this direction, so you can look into that. Whoever actually working in this particular domain can have the idea, can do the work in that domain, in that particular direction. Okay, so my last question is that we have basically we came across in many times what exactly the Archibald was also telling, that the point this means people are actually trying to measure the risk. Okay, and probably the next step it would be there is that whenever you are going to measure the risk, definitely the risk assess will be given a intimation that that is a risk, so the you have some particular alerts will be there. Okay, so is those particular paper what exactly you have basically read into this particular survey paper, is there any point that what is the rate of the false positive false positive of these
No.
particular models? Because this
That
could be very important one. Many times you are doing the your legitimate transactions. If it is in a marked as false, it's an alert. That might be a wrong thing for the system, and it might be losing the trust on the platform of that particular customer. I think so. Okay, so that is very important point. You will also note this one, Achisman, and it's your group. And those who are actually working in this particular domain, they definitely point these particular, note it down these points. These are very, very important. Okay. The other people can ask the question. I think Pritha have some question. Arun, Shrutishna, all of them have some questions. You one after another, you just turn on your mic and talk with madam and ask the question.
My question is, how is using LLM style training for graph AI different from traditional methods? And what makes it difficult to adapt these models for fraud detection?
is like in traditional method, as I like isolation they treat. Okay, they doesn't like see the like relationship between the entities. So in case of these graph neural network, that limitations are we can overcome with that treating each entity or transaction in isolated manner, that can be overcome. And what about LLM you are asking? Can you ask me again?
Yes, I
Like
asked
in,
how it differ from a traditional methods.
yes, it is different from traditional method in that way. In traditional method, all the transactions are treated in isolation. So it means the pattern, complex pattern. And nowadays, the those who do these type of fraudulent activity, they have also become smart. So it is not straightforward. So a model that we must develop, which can detect that complex patterns. So that's why these models are like more prominent for these challenges rather than rule-based methods and all other like static machine learning models.
Okay, thank you.
I would ask
Thank
Arun to raise your point and ask the question.
Yes, sir. Ma'am, I wanted to know that how we can evaluate whether the explanations generated by the GNN are actually understandable or actionable for fraud analysts, rather than just being technically correct from the model's perspective.
That whatever answer that like explainable AI you are asking, no? That what explanation it is giving, whether it is correct or not, how you will understand. So we must
Yes, ma'am.
validate it. We must validate it. Like first we must see that what like from ground truth we must validate whatever output it is giving or whatever explanation it is giving, whether it is correct or not. We must validate it. So some truths will be there already now. So we can compare whether the model is.
I would ask the other people to ask the question little bit quickly, and because the session is going to close, means now we are actually running out of time. And definitely 2 to 3 questions might be quickly be asked. I would ask Shutishna and Tushit to ask the questions.
Yes, so my question was, can GNN be used in a to make network analysis in a social trading network?
Social trading, yes, it can be used if you can represent that relationship and you can train your model, it can be used.
Okay, can it make some
to
special?
detect.
Okay.
Yes, it can detect that fraudulent activity over there also. Yes, tell me what. asking?
Can it make some special analysis that traditional networks can't, traditional methods can't?
Yes. Yes, obviously. In graph we can represent the complex relationship, no, and it can understand the features automatically. So it is like beneficial graphing.
Okay.
My question is, current models are batch trained. What architectural changes are needed to achieve the second response time required for real time fraud detection?
For real time fraud detection, what architectural? Uh, can you
Changes.
please ask me the again? You asked me the question.
What architectural changes are needed to achieve the sub-second response time required for real-time fraud detection?
For
Uh,
real time fraud, yes, sir.
uh, uh, Actually, what's might be she might be trying to understand over here means, let's say for example the data, if it is in a temporal data you are handling, and then what the changes are required in your model, that she's might be trying to understand, if I'm not wrong. Shrutisna, is it
Hi.
your
Yes,
question?
yes.
Okay.
Yes, sir. So dynamic, these graph neural networks are used so that it can capture these dynamic like activities. And also we have the type of like graph neural network where this temporal data can be captured. So we can use these particular sequential model like graph temporal networks we can use. And even we can like we can use one or two models to like as per the requirement what we are basically detecting or trying to understand. Okay. So
Okay,
and
ma'am.
for data privacy and all that we can use like federated learning. Yes, thank you.
Okay,
Any other questions?
I think we have covered all of the questions in the chat box by now. Does any of the audience have any more questions? I think not. Okay. Thanks a lot, ma'am. With that, I think we come to an end of our third reading session of MindSpec Research Lab. Uh, for everyone attending, I would like to mention that very soon all the presentation PDFs will be made available on our website. So if needed, you can always refer back to them. And thanks a lot again, ma'am, for your wonderful presentation.
One small announcement, also very important. Mithuna, we always post the feedback form in our reading session group in your WhatsApp. Please fill it quickly as soon as possible, because this feedback will help us to enhance our next upcoming sessions. Thank you. Thank you, madam.
Thank you, sir.
Thank you.